Hey gang, this is Slew, and we're counting down to the L-Cross impact. We're looking at the moon, and no matter how you're doing it, here at Slew, we're using NASA. If you're listening to this, well, then you're not here by accident. You know that this is a very exciting time, because for the first time ever, we might finally solve the mystery of whether or not there is water on the moon. We're looking at the southernmost areas of the moon right now, live here at Slew. Well, this history, let's go into a little bit of history from it. You know, it probably dates all the way back to July 20th, 1969, and the first landings on the moon. And right from the beginning, it looked awfully bad that there would be anything found that could be usable so far as ice or water is concerned, and we need water. We human beings need gallons of it a day, and water is heavy, and so it's expensive to bring to the moon. If ever in the centuries to come we're to establish a colony or a permanent presence on the moon, we're going to have to haul every drop of water that we humans need, unless we can find some there. Water weighs 8 pounds, about 4 kilograms per gallon. And we're talking about a kilo per liter, if you're used to the metric system. And that is heavy. A cubic foot of it weighs 64 pounds. So if we have to bring water to the moon, we're not going to go there. We're not going to ever have a presence of more than a few days at a time. So the first analysis of the 800 or so pounds of moon rocks that all the Apollo missions, all 6 of them, brought back regolith, which is the powdery, very fine baby powder, talcum powder substance from the moon's surface, as well as a number of moon rocks, and they were all anhydrous, meaning there's no water in them, and you can't even squeeze water out of them chemically. And then we suddenly got hope. About 20 years ago, the Army's Clementine satellite, orbiting the moon, detected the hydrogen signature over the poles that could possibly have meant that there is hidden ice in the dark vampire layers at the lunar poles. And this only happens because the moon happens to orbit straight up and down. There's only a few bodies in the solar system whose poles never get direct sunlight. Mercury is one of them. Jupiter is almost another. Jupiter is only tilted about 3 degrees. And the moon is another. So because of that, any depressions in the polar regions are places where the sun shines at such a steep angle that the floor of these craters or depressions simply do not see the sun. And that means the temperature falls to about 100 degrees Kelvin. And we're talking about over 200 degrees or so below zero. A good 300 plus degrees below zero Fahrenheit, and that's plenty cold enough for ice to remain. If it is ever there once, it's going to remain. So what could bring the ice there? Well, again, comets crashing into the surface of the moon, and we know that this has been going on over and over and over again for billions of years. We also think that the solar wind, delivering, as it does, a steady stream of broken bits of hydrogen pieces of hydrogen atoms, the protons, the neutrons, the electrons from hydrogen, might cobble together whole atoms of ice over the eons. And so because of that, there's every reason to think that that could have happened, and it might be there. Clementine said yes. A spacecraft after that failed to detect the signature that might indicate water on the moon. And then more recently, we had another spacecraft, the Lunar Prospector, that did find a hydrogen signature. So with all of this intriguing but ambiguous information that's come to us, it's time to find out. One way to be sending a spacecraft plummeting into a crater very close to the South Pole, just 60 miles or about 100 kilometers from the South Pole. A crater named Cabeus. It's perpetually in shadow. It's the place to look, and smashing into it at over 2,000 miles per hour. There will be 2 parts to the spacecraft. The first part is simply the booster rocket, the upper stage, called the Centaur. And we've been using this for decades, of the reliable Atlas V rocket. This is one of our workhorses in the United States to take spacecraft beyond the Earth, usually into Earth orbit, but in this case to the moon. So the upper stage smashes into it, and just a few minutes later we get the follow-up spacecraft that follows it. It too is going to smash into the moon, but before it does that, it will fly through the dust that's been churned up by the first one. And as that happens, looking for it with an instrument called LEND, which is that's the acronym for the Lunar Exploration Neutron Detector. And simply by detecting the number of neutrons, you can figure out whether or not the atoms are atoms of ice or anything else. So in that dust, for the first time, it's going to be churned up, and we're going to see whether it's really there. For SLU, I'm Bob Berman, and we're 10 seconds away from watching the impact on the moon's surface. 5, 4, 3. Let's see what happens. I've got people around me here staring at it as well. There was the impact. Now we're looking right at the southern tip of the moon. Nobody knows exactly how this may look because it's never been done before. We're going to see if we can see a little bit of dust coming just from the edge, probably not too far into the sky. Now, it may take some time for this dust to be sent up high enough. I'd say if it doesn't at least rise 6 miles above the surface, we don't have a chance to see it. And it's going to take a little bit of time for it to do that. So the impact has already occurred, and we'll see if enough material has come up and whether it's come up far enough for it to catch the sunlight against the darkness of space right at the bottom of the moon, and whether we'll see a change, even if it's a smearing quality, in space right along the moon's edge. Tell you this, with any backyard telescope you wouldn't have a chance to see this. We actually have pretty good conditions here. If you glance up for a moment at the craters near the limb of the moon now, near the edge, you'll see that there's, you can see the terraced walls of the central mountains and the craters. In other words, we're seeing detail, even at this very high magnification. And that's good. That shows that the atmosphere, Earth's atmosphere, is, although it's creating its usual bit of turbulence, we are, in fairly good shape. So if we're going to see the plume ourselves here live, we'll see it. We're still looking along the edge. Well, all this time, while I've been babbling on here, we've been looking for a plume in the south. And again, it would be a very, very small thing sticking up. I have not seen it. Now, it could be that on the NASA TV channels right now, they have even more powerful telescopes, and somebody's saying, oh yeah, there it is, but I sure don't see it right now, and so I'm just talking about what we're viewing. We didn't know what we would see. We thought it was potentially viewable. It's been very exciting, and still is exciting, to look, just as we at SLU, using our telescopes around the world, love to see Jupiter as it actually spins and its moons change. And if you don't know about SLOOH, S-L-O-O-H, make sure you try it out if you're new to SLU. And live astronomy in full color is something that's going to be happening even during the day, because we have observatories around the world, and it all depends on the weather. And I think the conditions at some of our other side of the world from the United States here may allow some at least wide field telescopes. Each observatory has 2 domes with different telescopes for different magnifications happening live while we watch. And I'll look for you there. So join us there at SLU. This has been a lot of fun. Let's find out what the analysis was during this historic occasion. I'm glad that you were with us here at SLU for this live inspection of the edge of the moon as the LCROSS satellite smashed into it. I keep calling it a satellite. It's really a spacecraft, space probe, because today we are going to find out what our future regarding the moon is. Very exciting times. For SLU, I'm Bob Berman.